Hey everyone, my name is Carson. I've been working on a field-ready system to hunt unidentified anomalous phenomena, or UAPs. I find that the shows and studies I've seen of everything from UFOs to ghosts to Bigfoot always sensationalize the event for entertainment purposes, and they lack a sense of scientific data collection, which is necessary to get the scientific community to take these phenomena seriously. The goal of this project is to create a system that can bridge the gap between sensational and the scientific. All right. So no project should ever exist without a purpose statement, vision statement, or mission statement. And so this is ours. Goal of this project is to provide synchronized data from multiple sensors to aid in the analysis and explanation of unidentified anomalous phenomena, UAP. The current UAP detector system consists of the following sensors: an all-sky camera, a telescope, a Kraken RF system, an ADS-B receiver, and a microphone array. Currently, the all-sky camera, the telescope, and the ADS-B receiver are functioning. The Kraken RF system and the microphone array were not functional at the time of this field test. For the UAP detector, I designed this GUI. The GUI's goals are one-click synchronized recording, which you can see in that bottom bar. I have the ability to check and select which devices, which sensors will be recording. I can hit record selected, and they all kick off at the same time and set up synchronized files on their local edge machines. At the top, you'll see the tabs where I can navigate between the EOIR sensors, the RF sensors, and the acoustic sensors. And then, of course, there's a suite of functionality as well as two video feeds, one from the all-sky camera and one from the telescope. And you can see all of that in this capture from the EOIR tab. Additionally, the goal was to maintain operator awareness of current status, regardless of which sensor is actively being monitored. So that bottom bar, which shows the date time group, the latitude, the longitude, the altitude, the azimuth and elevation, which you're pointing the telescope at, as well as the status of all of the sensors that are connected and what you're recording, that bar is shown across all tabs. So you always have a bare minimum that information that you can see at any given time. And lastly, of course, we don't want to hurt the user's night vision, so that's why we went with the black and green kind of scheme. Although after this field test, I feel like there might be some changes that need to be made to that color scheme. All right, some key takeaways to consider as you're watching this video. This was field test number 1, so it's going to be rough. The system is, I mean, this is its first light, so there's going to be a few pain points. Namely, I could never get the telescope and the all sky aligned the way I wanted to, and it got darker and darker and more difficult to get that set up. And so the alignment of the all sky camera and the telescope never really reached what I wanted it to. So we're going to focus on the all sky camera feeds for this video. The command plane timeout, yeah, my messaging framework that I use to send commands between my edge devices and my operator computer, I set the timeout way too low. It times out after about 5 minutes, and I really need it to allow me to come back to the GUI after 30 minutes or an hour and still be able to send commands. And the last major pain point was cable wrap. My mount doesn't have any sort of a slip ring. It's just a hobbyist mount. And so that leads to some cable wrap issues. But our successes, I mean, we saw the click point functionality worked even if the camera was not aligned, or sorry, even if the telescope was not aligned to the all-sky camera in quite the best way. I did see the click point functionality work just how I wanted it to. The ADS-B overlays, even though you'll see that they don't fit perfectly on top of the aircraft that they're supposed to represent, they are functioning, they are updating, and it worked as well as it could, given I couldn't get the all-sky camera aligned just right to the north-seeking vector. The video feeds and recordings were synchronized across devices at the edge, meaning when I hit record on the all-sky camera, which is on a different computer than the recording device for the telescope camera, they both hit record at the same time, and they both started a file simultaneously. And then the video feeds never got out of sync. There was never any sense of like one lagging behind the other or anything like that. So that was good. And then last but not least, the position and the telemetry, I should have said telemetry too, auto updated and that's huge. So I was never wondering where I was pointing. I was never wondering where I was sitting from a GPS standpoint. I was never wondering what were my camera settings, any of that. Um, so that's good. We overall this field test was pretty much what I expected. It was a little better in some ways, and then there were some frustrations that I knew were going to be frustrations, but could have been solved by getting to the campsite a little earlier with a little more daylight. Um, and then here's some functions that we're hoping to implement in the near future. I want to get the RF sensors working. I want to get the acoustic sensors working. Um, One that's going to be a really short near term goal is going to be the telescope pointing overlay on the all sky feed, so that I can see when I look at the all sky feed where I think my telescope is pointing. And then eventually I want to get a wider field of view telescope and a lighter and more reliable PTU. And then the big goal is the auto detection, auto record um, functionality, which is why I was gathering this data in the first place, was to write that part of code. All right, we're about to start the video, but a couple of notes before you go into this video. First, we're only watching the all sky feed in the larger windows. You'll be able to see some stuff going on in the telescope feed on the GUI recording, which will be in the middle on the bottom. But because of the alignment issues, this video is mainly featuring the all sky feeds. And the all sky feed will be two feeds of the same frame, one with overlays and one without. The one with the overlays has crosshairs, it has ADS-B overlays, so you'll see an iCow and a circle. That circle is supposed to be around the blinking of the airplane. It doesn't quite line up because I was not able to get my alignment right, but you'll see. Other than that, so keep a lookout for that. The circles won't be lining up with the plane location. Um, and at approximately 26 minutes into the video, the recording of the GUI will freeze. This is because of the way I recorded that video, not because the GUI crashed. So it's just going to be frozen for a good portion of the video, but that's okay. And then last but not least, there is at least one meteor that's captured in this video. So enjoy that. Feel free to comment with when it is if you happen to see it. And if you see any more, comment with when they occur. So without further ado, watch this video.